Hello, this is Rebecca Maloney, and I'm going to teach you how to use limit comparison to find the convergence or divergence of an infinite series. So the limit comparison test tests for both the convergence and divergence of a series. So you'll be given some a of n, and you will want to find a b of n that is similar to your a of n. Once you find that, you will take the limit as n goes to infinity of your a of n over your b of n. For the limit comparison test to be valid, this has to equal something greater than 0. If this is true, then if your b of n converges, then your a of n will also converge. And similar, if your b of n diverges, then your a of n will also diverge. Here are some practice problems. So you're going to determine whether the series converges or diverges. The first one is a sum from 1 to infinity of 1 over 2n plus 3. So your a of n is going to be the 1 over 2n plus 3. And for b of n, I'm going to take away the plus 3 and the 2 and make it 1 over n. So then you're going to take the limit as n goes to infinity of your a of n over your b of n. That will equal the limit as n goes to infinity of n over 2n plus 3. And since the power in your denominator is the same as power in your numerator, you can make it the limit as n goes to infinity of the largest power in the denominator. So n over 2n over n plus 3 over n. And that will equal the limit as n goes to infinity, 1 over 2 plus 3 over n, and that will equal 1/2. And 1/2 is greater than 0, so you know that you can use the limit comparison test. So then you find the b of n's convergence or divergence, and in this case, it diverges by p series. So then you know that your original a of n diverges by limit comparison. And the next problem is the sum from 1 to infinity of 1 over the square root of n squared plus 1. So your a of n is your 1 over the square root of n squared plus 1. And for the b of n, I'm going to take away the plus 1, and your square root of n squared will just become n. So it'll be 1 over n. So then you'll take the limit as n goes to infinity of your a of n over your b of n. And that will equal the limit as n goes to infinity of n over the square root of n squared plus 1. So like in the last problem, the powers of our numerator and denominator are the same because of the square root of n squared. So this can become the limit as n goes to infinity of n over n over the square root of n squared over n squared plus 1 over n squared. And this will equal the limit as n goes to infinity of 1 over the square root of 1 plus 1 over n squared. So then this will equal 1 over the square root of 1, which equals 1. Again, this is greater than 0, so you know that you can use the limit comparison test. So then your B of n is going to diverge by P series. So then you know that your A of n will diverge by limit comparison. Okay, then for this problem, you're going to start with your A of n, which is n plus 5 over the cubed root of n to the 7th plus n squared. Now this problem, for my B of n, I am just going to take away the n plus 5 in the numerator. I did this because when you take your limit, as n goes to infinity of your A of n, over your B of n, the denominator of your A of n and B of n will end up canceling out. So you'll have the limit as n goes to infinity of n plus 5, which will then equal infinity, which is greater than 0, so you can use the limit comparison test. So then to find the convergence or divergence of your B of n, you are going to want to use direct comparison, and you'll find that it converges by direct comparison. So then you can say that your A of n converges by limit comparison.